Okay, this video is on this egg slicing machine. You've probably seen it before. You take a hard-boiled egg and you slice it. You slice it with this wire cutting thing. So there's some really cool properties, mathematical properties about the surface area that happens. So the thing about this egg slicing machine is the spacing between the slices are the same. Every slice has the same thickness. So if we open up this egg, every slice has the same thickness. Now there are different diameters. Let's assume this egg is a perfect circle, a perfect sphere. So we have this end cap here and in these pieces with a smaller diameter, and then somewhere we have this piece with the maximal diameter. So now the question is, if we were to paint the outside of these guys, that represents the surface area, which piece would have the greatest surface area? Is it going to be this end cap here that has the greatest surface area? Or is it going to be like maybe the next piece? I'm talking just the exterior of the egg that we're painting. Or is it going to be the one with the greatest diameter here, if we were to paint this guy? Just the exterior of the egg, like this. Which one do you think has a bigger surface area? The edge of this largest diameter piece, or this end cap, or the other one? Well, it turns out each one has exactly the same surface area. Now this surprised me. The way I came across this was I was writing a computer program to generate points uniformly and randomly on the surface of a sphere. And then I wrote another program to check its correctness, to tally how many points in various coordinate systems. Like in the phi coordinate system, it should be uniform in the phi coordinate system, and it has some shape in the theta coordinate system, but then also in the x and y coordinate system. So I set up bins of uniform width and counted how many particles I generated in these various bins of uniform width. And when I looked at the answer, it was perfectly flat. I mean, up to some random noise in the bins. And I was like, what? I must have generated the points incorrectly, because I thought there was going to be some shape to the distribution. I thought like maybe the end cap would have less points than this other one that has a larger radius. But I said, what? How can that be? So then I did the integral, just using like basic kind of calculus stuff. You can do an integral. A semicircle has this equation, and there's a formula for the revolved surface area. So basically what this shows, if you integrate between any point A and A plus H is the width of the slice, and you do all this integration, you end up with something that only depends on the width. It doesn't depend on where you are. So you can slide this slice anywhere over, like the end cap. If the end cap has a width H, or close to the center it has a width H. So it's sort of trading off. Towards the edges, you have a longer like diagonal, but a shorter radius. And then as you get closer to the center, you have a longer radius, but the diagonal part is less. So it trades off just perfectly so that every piece has exactly the same surface area. So the next time you use one of these egg slicing machines, and say you have to give the eggs out to different people, and maybe they really value the surface area, they're all getting the same surface area, even the person with the end cap. Thank you very much.